Hello guys, so today we are going to be solving the fourth problem of Biweekly contest 71 of Leetcode. The name of the problem is minimum difference in sums after removal of elements. So let's first understand the problem statement. The problem statement states that we will be given an array of 3 into n elements, right? And what we have to do is we have to remove any subsequence of exactly n elements from the array. That is like initially we have 3 into n elements, then we will choose any subsequence of n elements and we will remove those n elements, right? So if you remove n elements from 3 n elements, 2 n elements will remain, right? So for the remaining 2 n elements, what we have to do is we have to calculate two values, sum of first and sum of second. Sum of first is the sum of the first n elements, that is the leftmost n elements, and sum second is the sum of the rightmost n elements, right? And the difference in sums of these two parts is denoted as sum of first minus sum of second, right? So we need to return the minimum difference possible between the sums of the two parts after the removal of n elements. Okay, so initially we have 3 into n elements. We remove one subsequence of exactly n elements, and after that we have to calculate the sum of the first n elements and calculate the sum of the last n elements and subtract the sum of last elements from first elements and return that value. We have to return the minimum difference that is possible. Okay, so let's look at the example first. So here nums is given as 3 1 2, right? So here 3 into n is equal to 3, that is the value of n is 1. So we have to remove any one element from it, right? So since we have only 3 elements, we can try all the choices. Let's first remove 3 here. If we remove 3, then our array becomes 1 comma 2, right? And here the value of sum first. Okay, let me write all these things now, that would be more clear. Initially I have this array, right? 3 1 2, right? I decide to remove 3 from it. Okay, then my array will become 1 comma 2. Now in this case my sum of first will be equal to 1, right? Because the value of n is 1. Sum of last will also become 2 similarly, right? So here my answer will be 1 minus 2 equal to minus 1, right? Okay, now let's go on to the second possibility and remove 1 from here, right? If we remove 1, then my array becomes 3 comma 2. Here sum of first is equal to 3 and sum of last is equal to 2. So here the difference becomes 3 minus 2 equal to 1, right? Since in the previous case we got a lesser difference than this, then we obviously know that this is not the answer, right? Okay, now let's remove the only option left, that is 2. So my array will become 3 comma 1. Here sum of first is equal to 3 and sum of last is equal to 1. Okay, so here my answer will become 3 minus 1 equal to 2. Now we already have a value that is smaller than this, so this is also not the answer. So my answer comes out to be minus 1. Okay, so it is given also here minus 1 and some explanation is given. You can look into it, right? Okay, so yeah, this is the question, and I hope the question is clear with the example. So first of all, let's just think about the brute force way of doing this problem, right? How can we solve this problem using brute force? The brute force way that comes into mind is of backtracking. What we can do is we can try to remove exactly n elements, like we can choose any n elements from the 3n elements. So the number of ways of choosing is 3n cn, that is 3n cn. C is combination, right? 3n cn. and we can calculate for all these elements. We can calculate for all these possible permutations and find the take the minimum out of them, right? But this would take a lot of time because since the number of permutations are 3n cn, right? 3n combination cn, and for every permutation, like suppose I have 3 into n elements and I have removed n elements. Now at the end I also have to calculate the sum of the first n elements and the sum of the last n elements, right? So that will also take linear time. So the complexity of that approach will be 3n cn, 3n combination n into 2n, right? And this would go like this would not finish in time because here n, the value of n is 10 to the power 5, right? So judging by the constraints, there are the only complexities that I can think of here is either we have to solve it in O of n or we have to solve it in O of n log n. So I was able to solve this question in n log n. Now how I was able to solve it is what we will discuss now. Okay, so just look at this example, right? Sorry, just look at what we have to calculate. We have to calculate sum of first minus sum of second after removing an element, and we have to minimize it, right? We have to remove an element and then we have to calculate this and we have to minimize this, right? So if you want to minimize the value of an expression, suppose let's say the value of sum of first is x and the value of sum of second is y, right? Suppose I am telling you that you have to minimize the value of this expression, right? So what are the two ways in which you can do that? One way is you can decrease the value of x, right? If you decrease the value of x, obviously the overall value of x minus y will decrease, right? Or you can increase the value of x, right? Sorry, increase the value of y, because if you increase the value of y, y will come close to x, right? And the value will decrease, and suppose it goes above x, suppose x is 5 and y becomes 6, then also it is beneficial for us because here the sign matters, so it will become -1, right? So either we can decrease the value of x or we can increase the value of y, or we can do both, right? If we are able to do both, then we'll get the minimum possible answer, right? If we are able to decrease the value of x and also we are able to increase the value of y, then we'll get the minimum possible answer for this particular expression. That's correct. Okay, so this was the main intuition for this problem, and based on this intuition I solved the problem. So what I did was for every I, first of all I am talking about x here. Okay, x, which is, I'm talking about sum of first, which is x, right? I'm assuming sum of first uh, as x, right? First of all, I have to calculate the minimum possible value of x, right? What x is? Now you have to think about what actually x is. X is the sum of first n elements after I have removed the n elements from the 3n elements, right? Initially I had 3n elements, right? Now I have removed n elements, a subsequence of n elements. Now 2n elements are remaining. Now what I have to do is I have to calculate sum of first, which is x, and it is basically the sum of starting n elements, right? Okay, so what I'm doing is for every I 0 to 3 into n minus 1, I am storing the minimum possible sum of n elements. I hope it is clear. For every I from 0 to 3 into n minus 1, I am storing the minimum possible sum of n elements, not subarray, the minimum possible sum of n elements up to index I, right? I'm just doing that in one vector, right? Similarly, for y, for every I am storing the sum, the maximum sum of n elements from I to 3 into n minus 1. I to 3 into n minus 1, right? Of here minimum sum from 0 to I, and here maximum sum from I to 3 into n minus 1. This will be stored in pref vector, and this will be stored in suffix vector, right? Yeah, this is what I am doing. And then when I'm iterating through the array, what I can do is I have till any index I already have the minimum sum of n elements from 0 to that particular index, so I can just take that value, and I also have the maximum value from I plus 1 to 3 into n minus 1. I can also take that maximum value, and if I take a minimum value for x and maximum value of y and subtract them, then obviously I'll get the minimum answer, and I'll do this for every index I, and at the end I'll have the overall optimal of the problem. I hope this is clear. So let's try this approach. Let's try this approach in an example. Let's take this example only. Okay, so I have this array. So here the value of n is, the total size of the array is 6, right? So 6 by 3 into 2, right? So my prefix array will be of size 3 into n. Okay, it would be of size 3 into n, and initially it would be initialized by zeros. Now what I will do is till n minus 1, like till n elements, I'll just fill it with the prefix sum. So it would become 7 comma 9 plus 7, which is 16, right? Now here I encounter 5. I want to know the minimum possible sum of n elements, but since I have reached here, there are 3 elements, right? And I have to find the sum of minimum 2 elements. So what I will do, like logically what I will do, I will check that whether the maximum value that I have included in my sum, whether it is greater than this or not. If that maximum value is greater than this current element, then obviously I can remove that value and insert 5 into it. That would minimize my overall sum. For example, here in my current sum first, I have 7 comma 9, right? Now I reach 5 and I see that there are 2 elements whose value is greater than 5, 7 and 9. So what I do is I decide to remove the greatest element. So what I do is I remove 9 from my sum. So my sum becomes 16 minus 9 is 7, and then I add 5 into it. So it would become 7 plus 5, 12, right? And currently my sum of first set contains 7 comma 5. I have removed 9. Now I reach 8. Okay, now I'll check that whether my sum of first set contains any element whose value is greater than 8. No, because it only contains 7 comma 5, right? So I'll move on and my sum will remain same. Then I'll go to 1. I'll check whether it contains any value which is greater than this, and I'll see yes, it contains 7 and 5. Both of these values are greater than 1. So I'll decide to remove the greatest value. So I'll remove 7 and then I'll insert 1. So my sum will become 5 plus 1, 6, right? And then I'll come to 3. I'll see that whether there is any element which is greater than 3. Yes, there is 5. So I will remove 5 and insert 3. So this would become 3 plus 1, 4. Right? So this would be my prefix array. Similarly, for suffix array, I'll start from the end. And here I want the maximum value. Here I was looking for minimum value, but here I want the maximum value, right? So I'll start from the end, and like I'll just first fill similarly for like starting an elements, I'll first fill for the ending an element. So it would become 3 here and 4 here, right? Yeah. Now I will come here, uh, here 8, right? So I will check that whether there exists any element whose value is lesser than my current element. Now the current set has 1 comma 3, right? Both of these values are lesser than 8. So what I will do is I will remove the smallest value because that is optimal. If I have to maximize the value of the set, then I'll always remove the smaller value and insert a greater value, right? So I'll remove 1 and I'll insert 8. So the sum will become 8 plus 3, 11, right? Similarly, I'll come at 5 and I'll see that whether there exists a value which is lesser than 3, because I have to maximize, right? Which is lesser than 5, sorry. So yeah, there exists 3 which is lesser than 5, so I'll remove 3 and the sum will become 8 plus 5, 8 plus 5, 13, right? Then I'll come to 9. I'll see whether there exists any value which is lesser than 9. Yes, there exist 5 and 8, but I'll remove the smallest one. I'll remove 5. So the sum will become 9 plus 8, which is 17. And then I'll come at 7. Uh, my current set contains 8 comma 9, so there is no value which is lesser than 7, so I won't do anything and my sum will remain 17, right? Yeah, okay. So yeah, this would be my suffix array, right? So now what I will do is I will start from iterating from I equal to n minus 1, right? From here, I equal to n minus 1, which is 1, right? So what I will do is I'll initialize my answer as the maximum value, let's say infinite INF, okay? And I'll start from I equal to 1. So here my answer will be updated as min of answer comma prefix of I. It is the minimum sum of n elements from 0 to I minus suffix of I plus 1, which contains the maximum sum of n elements from I plus 1 to 3 into n minus 1. So here prefix of 1 is 16 and prefix of and suffix of 13, suffix of 2 is 13, right? So here answer will become 3 since initial value of answer here is infinity. Then I'll increase my n, I'll go to 2. Here for I equal to 2, I'll see that the value of prefix of I is 12, 12, and the value of suffix of I plus 1 is suffix of 3, which is 11. Now here my answer is 3, so here it would take the minimum value, which is 1, so answer will become 1, right? Then I'll move forward to 12. Here I will become 3 and here it becomes 12, and here the value is 4 of suffix. 12 minus 4 will become 8, but that won't be the answer, so my final answer here will be 1, right? And I will return it. Okay, and yeah, the final answer here is also 1. Yeah, so I think the approach is pretty much clear now. So the only thing that remains here is how to keep my current elements into the set, like how to know which elements are currently present in sum of first and which elements are currently present in sum of seconds. So for that we can just simply use a multiset. We can use other things also, but I just thought of using multiset. It was intuitional for me. It was like intuition, so I decided to use multiset. So let's look at the code. First of all, I took the size of the vector, then I declared a multiset named s, and I declared a variable ll sum equal to 0. Here ll is long int, right? So what I am doing is similarly I am doing here is I am till 0 to n minus 1. See n by 3, here n is actually 3 into n if you are seeing, because here n is the total size of vector, you know. So I'm going till n by 3 and I'm just adding the current element into my sum, and I'm inserting the current element into my set, that this element is currently present in my set, and I'm doing prefix of I equal to sum, right? Which I explained here that for the starting an element just write the prefix sum, and for the ending an elements also just write the suffix sum, right? Okay. One thing also why I use multiset is because there can be repetitions. Yeah. So just because of that I use multiset. And for the elements starting from I equal to n to 3 into n minus 1, that is n by 3 to n, what I'm doing is I'm checking that whether the greatest element that is currently in sum of first is greater than v of I. If it is greater than v of I, then I would obviously want to remove this element and insert a smaller element, because I have to minimize the sum of first, right? So what I will do is, here I have checked star prev of s dot end is greater than v of I if the greatest element is uh, greater than v of I, because a multiset is always sorted, right? So if this is the case, then what I'll do is I'll take its value star prev of s dot end and I'll remove it from the set, and then I'll update my sum to sum minus x. I have removed x, the largest element, and I have added plus v of I. So I'll insert plus add v of I, and then I'll insert v of I here, and my sum has been updated here, so I'll just store prefix of I equal to sum, right? Then what I'll do is I will clear my set, and I'll initialize my sum as 0, and I'll initialize I equal to n minus 1. Then I'll do a loop for n elements similarly, and for the suffix part I'll just do the suffix sum and store it there, which I am doing here. Then from after that, uh, what I will do is, here I have to calculate the maximum possible value of sum of second, which is maximum possible value of n elements. So here I will check is if there exists if the minimum possible value in the current set is lesser than my current element. If it is lesser, then I'll remove that and insert a greater element, right? So that is what I'm doing. I'm checking whether it is lesser than v of I. If it is lesser than v of I, then I'm just taking its value, removing it from the set, then I'm updating my sum as sum minus x plus I, v of I, just like above, and I'm inserting v of I in the set, and then I'm doing suffix of I equal to sum I minus minus, right? Then I'm just starting my iteration, checking for all possible I. I'm starting from I equal to n by 3. Sorry, I equal to n by 3. I equal to 2 into I, because I have to go till 2 into n. Like, that is very clear, right? So here I will start with n by 3 minus 1 to j less than I, j plus plus, and here I'll just take the minimum value, answer equal to minimum of answer. Yeah, I wrote it in this way, prefix of j minus suffix of j plus 1. So I hope you don't get confused. And at the end, we'll get the minimum possible value, and I'll return that. So let's just submit it and check. Yeah, this is getting accepted. So this was the question. I'll post the code in the description, or in the comment section. So I hope I was able to uh, help you in understanding this question, but if there are any kind of doubt, then you can post freely in the comment section. I'll reply to that. Okay, so yeah, thank you for watching and have a very good day.